Today we're jumping into something absolutely core to how we experience the internet, the huge demands on modern web applications. I mean, just think about it. Every app, every site is constantly being pushed. Faster performance, tighter security, and honestly, just making them easier to manage behind the scenes. And the real shift, cloud solutions. They're really changing the entire game. So our mission today is to explore this world of cloud backend development options. We'll look at what's out there and the problems they solve. And we're basing this on a really great LinkedIn article. It's called Cloud Backend Development Options and Challenges, written by a software architect over at DSS Consulting. We're going to pull out the key insights, the really important bits, to give you a shortcut to understanding this whole fast-moving area. Okay, so let's start where the article does, really understanding the friction points. Before we get to the shiny cloud stuff, what makes those traditional backend setups so tough for developers? You know, things like the big all-in-one monolithic systems, or even microservices in that classic three-tier structure, presentation, logic, data. What are the headaches?
Yeah, that's a great place to start. The article really points out these inherent complexities. First off, just getting the thing deployed. Deployment, CI/CD pipelines, just keeping it all running day to day, that's a huge hurdle.
Right.
Often, developers are suddenly expected to have skills way outside their main job. Like they need to be PowerShell wizards or know the ins and outs of specific DevOps tools or understand the runtime environment really deeply.
Yeah, like JVM tuning or OS specifics. That's a lot to ask.
Exactly. It's asking a lot, and it distracts from, actually building features.
It's like asking the chef to also fix the plumbing and manage the servers. Just too much overhead.
Precisely. Then there's the whole rollback issue. When a deployment goes wrong, and sometimes it does, right?
Escalate.
You absolutely need a solid way to go back to the last working version. And designing that rollback process, it can get incredibly complicated, especially with bigger interconnected systems.
I bet. Nightmare fuel for ops teams.
Totally. I've seen teams lose whole weekends on a bad rollback. Then another layer the article mentions is minimizing service disruption during updates. Users expect things to just work always. So deploying a new version without any downtime adds, significant complexity to both design and operations.
Zero downtime deployments. The holy grail, but hard to achieve traditionally.
Very hard. And finally, scalability. This is probably one of the most critical things for modern apps. You need to handle sudden traffic spikes instantly, right?
Absolutely. Can't have the site falling over during a big event.
But getting that kind of elastic scalability in traditional architectures, it's really complex. So many factors influence it, database bottlenecks, network latency, you name it.
Okay, so deployment headaches, complex rollbacks, uptime pressures, scalability challenges. Quite a list of pain points. So if those are the problems, where do cloud solutions start offering, real answers?
What's fascinating, and the article highlights this well, is how similar the core solutions are across the big cloud players. Google, Microsoft, Amazon, they offer surprisingly comparable approaches.
Interesting. So you don't need to be an expert in every single vendor's specific settings.
Not necessarily for the initial architecture, no. If you understand the basic technology like what FAS is or how containers work, that understanding is transferable. It means the whole decision-making process kind of flips.
How so?
You first pick the technology and the architectural pattern that actually fits your application's needs. You think about that first. Only then do you start comparing the specifics, the features, the pricing, the surrounding ecosystem from different vendors like Azure, AWS, or Google Cloud.
Okay. So architecture first, vendor details second. That sounds much more flexible long-term. Less chance of getting locked in early.
Exactly. It's a big shift from maybe picking a platform and then trying to make your app fit its constraints.
Got it. Okay. That strategic view makes sense. So, with that in mind, let's dive into the specific cloud solutions the article discusses, these alternatives to the traditional ways. Let's start with maybe the buzziest one, Functions as a Service, or FAS. What is FAS, really, and how is it so different?
It's fundamentally different in how you structure your backend. Instead of one big application handling everything, or even several large services, with FAS, you break your logic down into individual functions. Each function is built, deployed, and scaled as a separate unit. Think tiny, focused microtasks.
Okay, tiny tasks. And the big names are?
You've got Azure Functions, AWS Lambda, Google Cloud Functions, those are the main ones. And the really revolutionary part is how the cloud platform handles everything else for you. Scaling, availability, triggering the function based on events, It's all automatic.
Automatic scaling, that sounds huge.
It is, and the event-based execution is key. Your function code literally only runs when it's triggered maybe by an HTTP request, a message in a queue, a file upload, or just a scheduled timer.
So it's not sitting there running, waiting for work.
Exactly. It only runs when needed, and that has massive implications for cost. You're paying for compute time only when your code is actually executing.
Right, like that taxi analogy, only paying when the wheels are turning. That could save a lot compared to servers that are always on.
For many workloads, absolutely, especially things with variable traffic. Plus, they integrate really easily with other cloud services, databases, storage, messaging systems.
But it sounds like it requires a different way of building things.
Oh, definitely. It demands a different development logic. You really have to think in terms of events and small, stateless functions. It pushes you towards an event-driven architecture.
Okay, FACE is about small, event-driven, auto-scaling functions with pay-per-use pricing. Makes sense. Now, lots of people aren't starting from scratch. They have existing applications they want to move to the cloud. This is where containers often come up, right?
Yes, container-based services are a very popular route, especially for migrating existing apps without needing a total rewrite.
How does that work?
The basic idea is you package your application or parts of it along with all its dependencies, the code, runtime, libraries, system tools, into these standard units called containers. Docker is the most common tool for this.
Okay, so it's like a self-contained box for your application component?
Pretty much. And then you run these container boxes on the cloud provider's platform. There are different levels of service here. For simpler cases, you might use something like Azure Container Apps, AWS App Runner, or Google Cloud Run. They handle a lot of the orchestration for you.
Easier to get started?
Generally, yes. But if you need more control, maybe for complex microservices or specific networking needs, then you'd look at the managed Kubernetes services. That's Azure Kubernetes Service, AKS, Amazon EKS, or Google Kubernetes Engine, GKE.
Kubernetes. That gives you more power, but it's also more complex to manage, I hear.
It is. There's a steeper learning curve. But the big advantage of containers overall is creating these customized runtime environments. If the standard PaaS or serverless environments don't quite fit your app's needs, or if you have really specific configuration or networking requirements, containers give you that control.
Right. So flexibility, portability, good for migrations, but potentially more management overhead, especially with something like Kubernetes.
That sums it up well.
Okay, so we've got FAES for tiny functions, containers for custom environments, and portability. What about the middle ground? Platform as a service, or PaaS. How does that simplify things?
PaaS is really designed from the ground up to make running applications simpler. The whole point is to take the infrastructure management burden off the developer's shoulders.
So less worrying about servers and operating systems.
Exactly. Services like Azure App Service, Google App Engine, or AWS Elastic Beanstalk, they manage the infrastructure, the OS patching, the networking, scaling, versioning, high availability. All that is largely automated.
That sounds appealingly simple compared to managing containers or VMs.
It is. Compared to container services, PaaS definitely gives you fewer knobs to twiddle, fewer configuration options. That's the trade-off.
Less flexibility.
Less flexibility, yes. But in return, it's significantly faster and easier to deploy something. You typically just provide your code or maybe a simple package, and the platform handles the rest. You're not building custom container images. You're not managing an orchestrator like Kubernetes.
So speed and simplicity, but you sacrifice some control over the environment.
Precisely. So PaaS is often recommended when your main goal is getting a stable service deployed quickly. If infrastructure flexibility isn't your top concern, and the runtimes and tools the PaaS provides are good enough for your app, it can be a very efficient choice.
Like the pre-built house versus building from scratch analogy you used earlier, PaaS is the faster, easier move-in, but less customization.
That's a good way to think about it.
Okay, fantastic overview of the main options. FAS, containers, PaaS, each with its strengths and trade-offs.
So bringing this all together, how do these different cloud approaches fundamentally change how we think about back-end development today? What's the big picture takeaway?
I think the biggest takeaway, and the article really drives this home, is that embracing cloud native isn't just about adopting new technology. It's a fundamental shift in mindset.
A mindset shift. How so? The goal isn't just deliver code that works anymore. It's about delivering and operating a service effectively. That means operating it flexibly, ensuring it scales efficiently, and doing all that while keeping operational costs low.
Right. It's the whole life cycle, not just the initial build.
Exactly. And FEA, containers, PEZAs, they're all tools optimized for different aspects of that lifecycle. They let developers build architectures that can precisely meet specific needs, whether it's rapid deployment, extreme scalability, or custom environments. And a really powerful idea is combining these. You might use FAS for event processing, containers for complex services, and PEZAs for stable web frontends, maybe even mixing services from Azure, AWS, and Google Cloud.
Building a hybrid ecosystem.
Yes, to create a system that responds much faster to new business requirements, improves availability, and automates huge chunks of the deployment and scaling process. It's about agility and efficiency.
That's a great summary. We've covered a lot today. We started with the real challenges of traditional backends deployment, rollbacks, scaling. Then we saw how cloud solutions offer compelling alternatives with interesting similarities across providers, encouraging that architecture-first approach. And we really dug into the specifics. FIAS for event-driven cost savings, containers for flexibility and migrations, and PIAS for streamlined deployment speed. Understanding these options really gives you a solid map for navigating modern web development.
Absolutely. And maybe a final thought to leave with you, the listener. Given how these cloud solutions are streamlining operations and enabling these new ways of building software, how might this whole evolving ecosystem completely change what skills are most valuable for back-end developers in the coming years? What does that future role look like?
A very powerful question indeed. What skills become essential? Definitely something to think about as you continue your own deep dives. Thanks for joining us. We'll catch you on the next one.